An array holds multiple values of the same data type under a single name, with each element reached by an index. To see why that matters, imagine storing 30 exam marks without one, 30 separate variables, 30 declarations, and any operation on all of them written out 30 times. With an array, you declare one thing and process it with a loop of 3 lines. That is the real argument for arrays, not that they save space, but that they let a loop do the repetition. An array and iteration are made for each other, and almost every array question in the exam is really a loop question. A one-dimensional array is a single list of elements, declared in pseudocode with declare, the name, the index range in square brackets, then the type. So an array of 5 names is declare names, 1 to 5 of string. Look at the table on the page. Index 1 holds Patrick, 2 holds Jane, 3 holds John, 4 holds Amira, 5 holds Ben. You read and write individual elements by index. Names of 3 gives you John. And note 2 things the syllabus expects. Every element has the same data type, which is what makes an array different from a record. And the index range is stated in the declaration. So an array declared 1 to 5 has exactly 5 elements. Using index 6 is an error, and one that produces a runtime failure rather than a warning. Now the pairing that makes arrays worth having. Filling an array, a for loop from 1 to 5, and inside it, input a value into the array at position I. 1 loop, 5 elements. Reading it back, the same loop shape, outputting the element at position I and totaling. Set, total to 0 before the loop, then inside, add the element at position I to total. Notice that last one is exactly the totaling pattern from topic 7, with the array element in place of a freshly input value, which is the point. The standard methods do not change because the data is in an array, only where the value comes from changes, and the initialization still goes before the loop for the same reason as always. A two-dimensional array is best pictured as a table with rows and columns, a seating plan, a timetable, or several marks per student. The declaration gives 2 ranges, class data 1 to 3, comma 1 to 2 of integer, 3 rows and 2 columns. Look at the values on the page. Row 1 holds 95 and 88. Row 2 holds 72 and 80. Row 3 holds 64 and 91. Both indices are needed to reach an element, and the order is row first, then column. Class data of 1, 2 is row 1, column 2, which is 88. Class data of 3, 1 is row 3, column 1, which is 64. Reversing the 2 reads a different element entirely, or one that does not exist, if the array is not square. This one is 3 by 2, so class data of 2, 3 would be asking for column 3 of a 2-column array, which fails. Walking a whole 2-dimensional array needs 2 loops, one inside the other, and the page states the rule. The inner loop completes in full for every single pass of the outer one. That sentence is easy to read and easy to get wrong, so let us watch it. The outer loop counts rows 1 to 3, the inner loop counts columns 1 to 2, total starts at 0 before both loops. Outer pass 1, row equals 1. Inner loop starts, column 1, so we read class data 1, 1, which is 95, total becomes 95. Inner loop again, column 2, class data 1, 2, 88, total becomes 183. The inner loop has now finished, so we return to the outer loop, row becomes 2, inner loop restarts from column 1, 72, total 255, column 2, 80, total 335, inner loop done, outer loop again. Row 3, column 1, 64, total 399, column 2, 91, total 490, and the loops end. Count the passes through the inner body, 6, 3 rows times 2 columns, not 5, which is what you get by adding them, and that is the error the rule is warning you about. And notice the order the elements were visited. 1, 1, 1, 2, 2, 1, 2, 2, 3, 1, 3, 2. Row by row, left to right. If a question asks in what order the elements are processed, that is the answer, and it follows directly from which loop is on the outside. A variation that questions like, totaling one row only needs a single loop, not two, because one index is fixed. To total row 2, you loop the column index from 1 to 2 and read class data of 2, col, with the row held at 2 throughout. 72 plus 80, 152. Totaling one column is the mirror image. Fix the column and loop the row. So the rule is simple, one loop per index that varies. Both indices varying means nested loops. One fixed means a single loop. If you find yourself writing two loops to total a single row, one of them is not doing anything, and that is worth noticing before the marks are lost. Searching an array is linear search from topic 7, applied to an array. Go through element by element until you find the item or reach the end. 2 implementation points worth care. First, use a flag, a boolean set to false before the loop and to true when the item is found, so that after the loop you can report not found rather than silently reporting nothing. Second, stop when you find it, either by exiting the loop or by making the loop condition depend on the flag, because continuing to search after a successful match wastes time, and worse, can overwrite the position you found. That second point is the one that separates a correct answer from a nearly correct one. 4 things to take into the exam. First, declare arrays properly. Declare name, the index range in square brackets, OF, then the type, and remember every element shares one data type. Second, for a 2-dimensional array, the order is row first, then column, and reversing them reads a different element or fails entirely. Third, with nested loops, the number of passes is rows multiplied by columns, not added, and the inner loop completes fully on every outer pass. So a 3x2 array gives 6. And fourth, use one loop per index that varies. 2 loops to process a whole table, 1 loop to process a single row or a single column. Almost every mistake in this topic is either an index in the wrong order or a loop count that was added when it should have been multiplied.